My name is Farامرز محمدی نژاد. I'm an industrial designer and designed, produced, and built numerous projects for the past 20 years. In this video, I will go over the process from idea to the product for an inventive household appliance, lemon juicer. A project was introduced as a lemon juicer for home use. During each year, in Iran, people use lemon juice a lot. That is being mass-produced in industrial plants. However, most of Iranians choose to get their own lemon juice from fresh lemon for their annual use. For this reason, they usually offer fresh lemon and either get the juice manually at home or take it to shops and pay them to get fresh juice. The project that began in 2004 in Jahanava Company, a household appliances manufacturer in Iran, was based on an additional accessory to an existing company's meat grinder. While that meat grinder was one of my designs that was produced and entered to market 2 years before. In this case, it was focused on a mechanism close to the existing grinding mechanism, which instead of meat will grind lemon, and then should separate juice from pulp and collect each one in separate containers. When designing products like lemon juicer, which is an added mechanism to an existing appliance, function is the priority. Therefore, aesthetic aspects are not quite on focus at the beginning. So after basic studies, the function was based on squeezing lemon, which was sketched in 2 different categories: cylindrical and conical chambers. Consequently, 2 different prototypes were made and tested, then all pros and cons gathered to find out each mechanism's functionality, ease of use, production and cost aspects, and finally aesthetics. After evaluations, conical shape was selected for next step. The 3D modeling began and was based on plastic injected parts with simplified forms and minimum number of parts with concentration on high efficiency, ease of assembling and disassembling, and also ease of cleaning. After discussion and brainstorming, we decided that main body should be transparent to make better monitoring and make the process visible. Lemon enters to the machine as not cut, so it needs to be cut in half. This action will be done at the connection point of inlet channel and main body. That line works as a blade. Some ribs are needed to prevent lemon spin inside chamber and just push lemon forward to be squeezed at the end of chamber. 2 outlets are needed to get pulp and juice out of machine. Size and placement of each outlet is very important to define efficiency of mechanism. As lemon is squeezed while not peeled off, the amount of juice in skin determines quality of lemon juice. Because big amount of juice in skin makes lemon juice bitter. That is one of the main reasons people are not much eager to get lemon juice from shops with industrial juicers. The juice outlet channel is located at the very end of bigger side of cone. To be far enough, no pulp or seed get mixed with juice. For safety reason, the diameter of each tree channel is important, which no finger could get into the chamber during operation. Then, after conclusions to finalize all dimensions, materials, and machine elements, drawings were sent to tool makers. Injection molds are made one by one, and for speeding up the process, parts are splitted between many tool makers. Afterwards, molds are tested with injection machines to get sample parts. Upon the design validation with sample parts, some problems observed which need to be solved. Contact between moving part and the static part, spiral shaft and neck needs a bearing, so a phosphor bronze bearing is added to the design. That bearing must be placed inside the neck part's mold, and after injection, it will be fixed in its place. The lemon juicer assembly is like a cantilever beam. Therefore, to increase sturdiness on joint which connects lemon juicer to the main machine, we need reinforcement. Some vibrations were observed, and in order to reduce that vibration, an aluminum die-cast part designed and placed in the nose mold to achieve that needed reinforcement. The result was wonderful, and all vibrations were gone. During functional test, in the process of cutting half, some cracks were observed in the area which is shown in the figure. We decided to increase the density, and afterwards, on next functional test, no more damages were observed at the point. The back knot is so tight after each use.